Okay, this is on section 2.3, worksheet number 1, and basically it's some new stuff. We have 4 days of new stuff, then a review and a couple tests. So here's the 2.3 number 1. The first type of question we're going to talk about is transformations. Do you remember what x cubed looked like? There was 12 parent functions. This is one of them. You remember this one? Okay, stay focused. You okay? You look stressed. Yes. You okay? All right, good. All right, so this is x cubed. Remember that one? Now what if I did some weird stuff to it like this? I put a 2 in front, and then I put an x minus 5 in there, and then I cubed it, and then I put plus 7. You remember how the whole order, like you have to do things in? That's coming up again, so we need to make sure you get that. I suggested you always start where? Inside, and what does that one mean? Right 5. And then you go to the outside, and which one should be first, A or B? A is first, so that's a 2. It's not a 2 stretch, it's a vertical stretch factor of 2. And then the last thing is the up 7, which you can just say up 7. Okay, now the only way this gets much more complicated is if there's this, and then there's either parentheses in there or not, and so let's talk through that part. If you've got a 2 in there, now on the inside there's 2 things. Which do you pick? You pick the one that's not in the normal of order of operations. Remember, it's opposite of normal. Do you get that normally that multiplied by 2 should be first? So we don't do that first. So we do this right 5 first. Then we do this, which is not a stretch of 2. It's a shrink, horizontal shrink factor, not 2, 1/2. And then you move to the outside, and it's the same as before. It's vertical stretch 2, and then up 7. Okay? See if I can catch anybody on this one. I'd like you to make a number from 1 to 5 and tell me what order you think this should go in. There's that, and that. 5 things. Tell me what order this should go in. Shh, don't say it. Write it. Use the pencil. Or pen. Mr. U, write them down. At least you could start with numbers. Now, it is easy to get confused on the inside there. Before you get too far, if you're doing it wrong, I want to catch you here. Once you're inside these big parentheses right here, there is another set of parentheses. That cell phone goes on my desk and goes down to the office. You can't be texting during class. Move it up there. Thank you. Make it fast. This is normally first because it's in parentheses. So it's not first. So therefore, this one should have been first. Raise your hand if you knew that. Awesome. That is not a horizontal stretch of 2. It is a horizontal shrink factor 1/2. All right, that's easy to get confused on. You're really comparing not multiply and subtract. It's not like this and this. You're comparing parentheses with multiply, and parentheses are always first, so therefore they have to be last. All right, so then that right 2 thing comes in. And now we move to the outside, and on the outside there's the 3 or the negative, and frankly, I don't care which one you put next, because it's okay to have either one. I recommend you stretch before you flip, so the stretching would be the 3, so that'd be a vertical stretch factor 3, and then the flip, which is a reflect over which axis? Good. And sorry, I'm writing really too fast here. And number 5, the last thing is the up 4. All right, so there's your order that you got to do things in. Okay, any questions about that? All right, if you were going to make a sketch on this and actually try to draw this thing, I would suggest, if you're just sketching, it's fine to try to do all these move and flip and then move it again and then stretch it and all that stuff. But if you had to get an accurate graph, if it was a graphing test, what's your best friend? XY chart. Because you can go back to that, even if you have totally forgot what XY or what X squared looks like. You could know it by just saying, oh, put in a number. Pick any number. I want to pick 2. 2 would be smart because that'll make this 0. And then 0 times 2 is still 0, and then squared is still 0, and then that's all 0. 0 plus 4 is 4, so see, I got a point already. That's one of my many points I would need to graph to get an idea where this parabola was. All right, just don't forget for the graphing test, XY charts are gold. Okay, moving on. On the next part of the worksheet, they're going to ask you about extrema. If you graph an equation, it's kind of easy to tell where extremes are. They're the low spots and the high spots. Okay, so this is an extreme point. This is an extreme point. Okay, and there's only 2 extreme points in this graph. Granted, this thing keeps going up forever, and it keeps going down forever on this side. That's called its end behavior. All right, so if I was going to describe this graph, I would say it has 2 extrema, they're called. And this one's a local max. This one is a local, what do you think? Yep, min. And this graph has no absolute maximum, meaning it keeps going up forever. So there is no max. There's a local max, like locally it's the high spot, but there's no absolute maximum. And there's no absolute minimum because the graph keeps going down forever this way. Next thing, you can tell by how many turns the graph has in it. Sometimes you can tell what degree it is from that. I really don't like to teach it this way though, because there's a lot of exceptions, like it works except for this time, and then of course that's the one that'll be on the test. So I don't want to give you that way of knowing how many turns it has in it. Like here, it made a turn, right? And here it made a turn, right? So there's 2 turns. So you could say it's probably, this is safe to say, it's probably a degree, what do you think? 3, good. Okay, but it's not always. Because sometimes there's imaginary roots in here, which always come in sets of 2, that can throw it off. So it could be a degree 3, could be a degree 3, but it also could be a degree 5, or 7, or 9. One thing I know for sure is if the ends are going in opposite directions, that tells me something important, that it's odd. This for sure is an odd degreed polynomial. Okay, which means if I wrote it out, it might look like this. Okay, that's possibly the graph of this one. Why? Because it has an odd degree for its biggest term. Remember, it's only the biggest one. It's not adding up the terms. You don't like, some people think you add this and this and say that the degree is 4. They're wrong. There's only 1 degree. It's the biggest one. All right, so this one's degree 3, and it's going to have the ends going in opposite directions. But remember how I was saying you can't be sure that that's a degree 3 because it might be a degree 5 or 7 or 9, as long as you keep straight that the ones that are odd go in opposite directions. Okay? Take a guess what happens on the even ones. Same direction. So if you have something that goes like this, notice on both ends it's going down, then that's either degree 2, 4, 6, 8, 10, etc. And then I could say how many turns does it have in it? Has 1 turn, 2 turns, 3 turns, so it's probably degree 4. But it could be degree 6 or 8 or 10 or 12 as long as it's an even degree. All right, so if I were you, I'd make even because the ends are the left end, and the way I usually say this is like this. Left is down. If you say increasing or decreasing, it can really confuse you because this looks like it's decreasing, but actually on that little interval, you read from left to right. So it's technically increasing right there. So you don't want to say that the left or right side are increasing or decreasing. Bad idea. Don't say that. Just say if they're up or down. So on the end behavior here, the left end, it's down. On the right end, it's down. So you just say up or down when you're talking about the ends, because increasing and decreasing can screw you up too much. All right. Next thing is the y-intercept. I have a really powerful statement that I want you to try to remember, and the inverse of it is also true. So that's actually 2 statements in one. The x-intercept is where y equals 0. You were in my class last year, weren't you? And it's going to come in handy because this is so important. The x-intercept is where y equals 0. A lot of people think that they can just look at the last number and that's always the y-intercept. It's not. If I go like this, You guys just had a test on this last week or week before, I think it was last week, where we said, what's the vertex of this thing? And you would remember, hopefully, that the vertex was what, comma what? -3, comma 7. Okay, good. And a lot of people think, oh, the y-intercept's at 7. Nope. In some forms of equations, the last number is the y-intercept, but it's not always. Therefore, don't use that rule. The rule you should use is the y-intercept is where, what did I say? The y-intercept is where what? X equals 0. It's the opposite letter. So the y-intercept is where x equals 0, and conversely, the x-intercept is where what? Y equals 0. You getting that? That's important. If you haven't already written that one down, unless you already know it, the y-intercept is where x equals 0, and the converse of that are really important. Okay, so how can I find the y-intercept of this guy if it's not 7? Because it's not. The y-intercept is where x is 0, so I stick a 0 here and find out what happens. What's that? 3, and then what's that? 9, and then times it by 2. And then you add the 7, and that makes 25, so y equals 25. What did I just find? The y-intercept. Notice it's not the number at the end. The y-intercept is where x is 0. So you can do that even on a crazy equation like this. And in this case, it is the last number. But how would I know for sure? The y-intercept is where what? X equals 0, so I stick in a 0, and that cancels out that term, and that term, and that term, and they're all gone, and then the answer must be 5. That's the way I want you to do it, because sometimes they'll be written in funny ways that just try to trick you, and it won't be the last number. The y-intercept is where x is 0. Okay, so if I give you this graph, tell me one point you absolutely positively know is on the graph. Y equals 5 or x equals 5? False. Y equals 5. Here's why. We're finding the x-intercept. Or no, we're finding the y-intercept. The y-intercept is where x equals 0. I put in a 0 here and here. The x's are gone. So therefore, what's left? Y equals 5. Okay? So that spot where y is 5, like a dot right there, that has to be on this graph. Next part, that whole cubed thing. This tells me that my graph has to have a couple turns in it. You know what I'm talking about? Okay? So therefore, if I go like that, I made 2 turns. Is that possibly the right graph? Yeah. Okay? The y-intercept is where x equals 0. I figured that out. I could also do the other way and figure out the what? The x-intercepts if I put in what? The x-intercepts are where what? Y equals 0. So then I could undo this thing and go, okay, well, the y-intercept was where x is 0, so the x-intercept is where y is 0. I stick a 0 here, and how do I solve a quadratic? This actually isn't, this is cubic, but if it had been a quadratic, you could solve it with the quadratic formula. You could factor it and set it equal to 0. There's lots of ways to do it. You could graph it and see where the 2 lines cross. Graph this, y equals 0, and graph this, and see where they cross. There's lots of ways you could get your answers for where they would touch. All right, so I want to know, I'm going to draw a picture, and I'm going to ask you, is that possibly the graph of this equation? Now prove it. It has not 4 terms, it has 3 terms, and therefore it has to be at least degree 4. And it also could be degree 6 or 8, because there might be other things we don't know about on this graph, like imaginary roots. And you'll understand more about that later. But for right now, just know that it's not a lock that it's degree 4. It's at least 4, but it might be 6 or 8. We know it's even, that much short. So this blue one cannot be right, because I'm looking for one that was odd. So if I back this up a little bit and say, wait a minute, I'm going to just do it a little different. There. That is an odd one. Could it possibly be the right graph? Prove it. Why is it not possibly right? The y-intercept. The y-intercept is supposed to be what? 5, because it's where x equals 0. And this one's in the negatives. That can't possibly be the right graph. Okay? So what you're doing here on this test, this is not for the graphing test. On this test, it's more about communicating and saying, not can you graph this, because you just set up an XY chart and you graph it. The part that you're trying to learn here is communicating on saying, Could that be the right graph or not? And the answer would be no, that can't be the right graph because the y-intercept is supposed to be 5 and this doesn't have a y-intercept of 5. All right. Next topic. I'm going to give you a picture. You tell me what you know about it. What's one thing you could tell me about this for sure? Degree is 4 or 6 or 8. It's for sure even, yes. Degree is even. What else? The y-intercept, we know the y-intercept. It's like 7 or whatever that is. Okay? All right, good enough. That's all you'd need to know for right now. Next is end behavior. If we looked at this graph, would you agree that the left and the right end are the same? But tell me you would not say decreasing because that would be wrong. What would you say? Down. They're just both down. It's either up or down. So a left end is down, right end is down. All right, one more thing. You can tell by looking at an equation whether or not the right end is going to be up or down. I can just tell you. On this puppy, I know for sure that the right end is up. On this one, I know for sure that the right end is down. Do you see what I'm looking at? Okay, that front number, if that front number that's called the lead coefficient, that lead coefficient is negative, then, do you remember it from a parabola? That if it was negative, it had to be doing this, right? But technically, all it really tells you is that the right end is down. Because otherwise, what would you do with odd ones? Odd ones, like this, ones that have odd degrees, have an end going up and an end going down. It's the only question is which one is going up and which one is going down. And you look at the lead number here, and that tells you if it's up or down. This tells me right here that the right end is down. And since it's odd, I know then that the left end is up. And what does that tell me? What's the negative 7 is the what? The y-intercept. Okay, so if I were to make a possible graph here, and this is what you'd have to do, a possible sketch of this graph, even though I know you don't know exactly where it is. You could always get it with an XY chart, but if you wanted a sketch of it, real quick, you could go, okay, right end's going down, and it has to go through negative 7, has to hit there, so now I just have to fake the rest of it. Could this possibly be it? No, because that's even. You know why it's even? Because both ends are going down. Okay, so that can't be it. So I can try faking it again. What if I were to go like that? I'm assuming I hit the point, okay? Could that possibly be this graph? Because its y-intercept is negative 7, and it's odd, and the right end is down, and it's odd because they're going opposite directions. See, you're learning lots of little things. All right. There's just a little bit more. Okay. The next part is how do I describe this picture using what's called a limit? You're going to learn limits in calc. We just do baby limits in here. Your limits are always very simple, and they will always look like this. I would take a note on this if I were you. The limit of this function as x approaches infinity or negative infinity or whatever, I'm telling you the framework that will always work for you, is equal to something. And these two numbers are the things you have to figure out for the graph. But I can guarantee you, if you write your answer just like that, that's how you write your answer for any of our limit questions. The red writing right there. It always looks exactly like that. You just have to figure out what the two question marks are. All right. Now, if I were asking you about the left end of this graph, the left end is this end. As x is approaching means x is getting closer and closer to. If we're moving this way, do you get that our x is moving to the left? We're going this way. That's the x direction. X is going way to the left. X is going towards what? Negative infinity. Very good. So as x goes to negative infinity, well, if they're talking about x on the one part, then the other part must be talking about y. And therefore, if x goes to negative infinity, if I go way to the left, what's y going to go towards? Positive or negative infinity? Nope. Y, look at it's going down, isn't it? I'm talking about the left end right now. Talking about the left end. As x goes towards negative infinity, I go forever this way. Do you get that the graph will be forever down this way? That's negative infinity. So for this graph right here, what I do for taking notes is I make a quick test of that little blue graph. And some of you are just sitting there like a lump. Hurry up, write something down, or I'll have to get on your case. X goes to negative infinity. Then this is the y spot. Y goes to negative infinity. Wow. Seemed like just a locker shook my whole smartboard. Somebody has a large pectorals. All right. If I were to graph the other side of this thing, I'd say the limit of the function. Notice I don't even have to know what I'm doing here. I'm just going to say that general thing. As x goes to is equal to. That's what you always start with. And kids forget it on the test so often. I get kids with the x goes to like up here or something. I'm like, how did you? I never did that. The limit where the x is underneath the limit, see? Now on the right side, way to the right, what's x approaching? Infinity, positive infinity. If I go way this way, and if I go way that way and extend my graph forever to the right, then do you get it will be way this way on the up-down thing? It'll be positive infinity. All right. Yes, ma'am. Yes, you do it on each side. You'll have to write two limits for each graph. So here would be a typical question. Here's a test question. Not the exact one, of course, but let's say we had a graph like this. They could say write limits to describe the end behavior of this graph. And you would say, well, I know it starts like this. Limit of the function as x approaches n equals. You have to have all those things, and then you just need to fill in two little things. This spot and that spot. Would you please try it right now? See if you've got this nailed. You should be able to answer this one really easy. How do you describe the left end? And then you'll also have to describe the right end later. You always do both. Mr. V, I know you can do this. The limit of the function as x approaches what? Going way left. Correct. X approaches negative infinity because we're going way over this way, and x is negative infinity over there. It will end up being what for the y? Negative infinity. Because as I go way this way, my graph will go way down here, and it's heading towards negative infinity. All right. The right end. It's different than when we took notes before, because it's still limit of the function as x approaches. But this time, way to the right still means positive infinity. But this time, when I go way to the right, my answer is going way down, see? So it's negative infinity. When I go way to the right, my function will be way down. When it comes to the y, it's negative, way, way low. Yes?
So, like, on that test question, will it have, like, a spot where you write the left side, where you write the right side?
That is, well, sometimes they'll just say,
like, left side, right side.
I don't know. If we were nice, we'd have left end and right end just to make sure you don't forget one. But we're not always nice, so I can't promise that. So make sure you've got both. If it's the letters labeled or not. Yes? Yep. It's a good question. Will the answer ever be negative, other than negative or positive infinity? Yes, if you have something with an asymptote. Let me give you an example. Do you remember this graph? Okay, if I go way, way, way to the left, over here I'm going to say lim of the function. As x approaches, and if I'm going way left, that's way this way, x is going to approach negative infinity. But my answer isn't positive or negative infinity, because do you get Mr. Thank you. That when you're going way this way, the y gets closer and closer and closer to what? The y value. 0. So the answer is 0. Because it gets closer and closer and closer to 0. Because see, even though it never hits 0, does it ever actually hit negative infinity either? No. So it never actually hits 0. So the minute it actually hits negative infinity, it would actually hit 0. Another way to say it is, these limits are what they approach. Not what they're actually going to touch, but what they get closer and closer to. This is going to get closer and closer to negative infinity as I move to the left. And its actual answer will never hit 0, but it'll approach 0. All right, let me see if you really understood this. Tell me the limit for this guy. You may or may not remember this, but we had a function that would limit out and have an asymptote number like this, and it never got higher than that. Okay, you're going to remember that function later. It's called a logistic function. Okay, but if this, the highest it ever gets is 100, then tell me, what's the limit of this function on the right end? Don't say it, write it. It includes lots of letters and symbols, and it's very calcy. You're going to do this in calc too. All right, here's the no-brainer part. Limit of the function as x approaches. Now, if I said right end, what's x approaching? If I go right end, x is approaching not 100, nope. X is approaching infinity. Then, how high will it get is the other answer. How high it'll get is 100. Okay, and we understand that when we're writing these, you're not going to actually get to 100. Just like you're not going to actually get to infinity. These are what's called approaching. You're approaching infinity on x. You're approaching infinity, or sorry, you're approaching 100 on y. All right, yes? For the left side on this one, good question. Limit of the function as x approaches, well, if I'm going from the left side, I'm going over this way, x is approaching what? Negative infinity. The answer will be 0. Very good. Because the highest it gets is 0. It gets closer and closer to 0. It never actually touches it, but there's an asymptote line down here too. So it never actually touches 0, but this would be the answer for the left end. This would be the answer for the right end. That's how to write limits. Okay, and that's just the first time. You're going to see so much more complicated limits later, but right now, that's all you're going to have to know for the test. They're going to get more complicated when we start having inner limits and outer limits, but for right now you're just doing the outer limits, the way end limits. The only thing to get more complicated on is if you have something like this, where you've moved the graph, and so it's like this. And then the question becomes, okay, left end and right end are pretty easy. This asymptote line, let's say it's approaching 8. As x approaches negative infinity, y would be 8. As x approaches positive infinity, y would be 8. But in the middle, do you get how it depends? If you're approaching the middle, approaching there, then it depends on if you're coming from this side, it's going down. If you're coming from this side, it's going up. So that's where limits get more complicated. It's not that hard. To answer this question, let's say that it's getting closer and closer to, let's say that's 6 right there. Then you'd say the limit of this function as x approaches, what's x approaching then if I'm going towards the middle? X approaches 6. See, as I'm getting closer and closer to 6, then what's the y doing? Well, I have to tell which side I'm coming from. Because if I'm coming from this side, then it goes down. If I'm coming from this side, then it's going to go up. So you tell which way it's coming from. And you'd say, well, if I'm talking about this side right here, then x is coming from the negatives. See, the negatives were over here? X is coming from the negatives. And then you'd say that the answer is that it goes down, 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 and so the answer would be negative infinity. All right, you are not there yet. All I'd ask you to do for today is something like this. Let's say I make an asymptote right there. No, let's not do that. That would be too complicated. Let's say there's an asymptote here. And my function goes like this. And I'd say, what's the left end limit? Try it. And that spot right there is 10. What's the left end limit? Try it. Write it. Write it. You're almost done, but you're not done. Lim. F of x. Always put the x approaches underneath the limit. I've been informed by the calc teachers. I was trying to, like, say, I felt bad for this kid on the test. There was a couple of them. We're writing it like this. The limit as x approaches infinity. Nope, have to mark that wrong. They want us to really emphasize. Because if you do this on the, if you take the AP tests on calc, they cannot accept that answer. The x approaching has to be underneath the word lim. No exceptions. Okay, so lim of the function as x approaches. What's x approaching if I'm getting on the left end? If it's going way that way, it's negative infinity. Good. And then how high will it get is the other part. 10. Raise your hand if you had that one right. Okay, good. And you get limits as much as you need to get them right now. All right, and the last part is just a review. And since you were gone for 4 days and ate lots of fowl, so to speak, turkey, then you might have forgotten how to do this. What if we say 3x squared minus 2x plus 7? Bet you don't see the vertex just sitting there, do you? Because it's not. So how do you get the vertex? X equals what is it? Very good. So it'd be negative b, which would be 2, over 2a, which would be 2 times 3 is 6. So the answer is 2, 6, which is 1/3. That is the x of the vertex. And then you'd have to plug it back in to get the y. Do you know what I'm talking about? So you plug the 1/3 back in here and here. And you multiply it all out to get the y. And then you'd have the vertex. Okay, just wanted to remind you how to do that quick. Okay, now I'm handing out the worksheet. It is on the way. I'm going to do the first couple with you. Keep that one. Actually, could you help me hand these out? You do this half the side of the class. Could you hand these out to your 3 rows? One to everybody. Okay, judging, thank you, by how well I prepared you, I'm hoping that this first question is almost insultingly easy. Focus, especially if your first name starts with an A. All right, number 1. Describe the transformations in the correct order and then sketch it. So remember, sketch is not a graph, it's just a quick sketch. So in order, there's 2 things to do. 1, 2. What's first? Right, 3. And the other thing? Vertical stretch of what? Factor 2. That's it. And now the quick sketch. Okay, quick sketch of this thing. Generally, what does the cube thing look like? I call it the John Travolta function. I think I've mentioned that before, because he kind of does this kind of a thing every now and then. Anyway, so this is your John Travolta function. And now I'm moving him right 3. And then I'm moving him where? Oh, wait, I have to stretch him. Okay, so then stretching it means I grab this end and I grab that end and I pull. And this spot stays the same, so it's going to look more like that. It just gets stretched out a little bit. Imagine that black function being made of rubber and you grabbed it and you pulled it. That's a sketch. That's good enough. If you really needed accurate points for a graphing test, you'd make an XY chart. All right, that's all there is for number 1. Number 2's just got like 1, 2, 3, 4 things in it, so you have to number from 1 to 4. And again, it's a sketch. It doesn't have to be perfectly accurate. Let's move on to problem 4, where it'll get more tricky. Stay on problem 2 if you want, but it's your loss. Number 4, f of x is negative x to the fourth. And what am I supposed to do this? Oh, plus 2x. And then it says graph it on the graphing calculator. Ooh, I've got a graphing calculator. I can do that. So everybody grab your graphing calculator. It says locate its extrema and zeros. Remember, that's the low spots and the high spots? And the zeros, by the way, are the x-intercepts. I'll help you see that on this first one. All right, quiet please. Stay with me. You should be on your graphic calculator typing in x to the fourth plus 2x. Or wait, there's a negative in front. Don't forget that. Isn't there a negative in front? Okay, good. So negative, we're doing problem 4 here. Negative is the minus, not the minus sign, it's the negative sign. It makes a big difference. You put a minus sign, it'll say error. Got to use the negative sign, the red one that's lit up on the board up there. Okay, negative x to the power of caret 4. Arrow over to get out of the caret thing. Negative x to the fourth. Oh, I keep looking at the wrong worksheet. Plus 2x. Plus 2x. Enter. Graph. Oh, my window's weird. Right away, I would stop it by hitting the on button, keep it from going on and on. Did you know it stops the calculator from calculating? If you hit the on button, it'll stop that annoying processing. Hit the on button. Anyway, hit zoom 6, go back to normal zoom, and hopefully I'll see my graph appear. There it is. Look at that. It looks like it has a high spot in it. That seems kind of important. How do I find that high spot? There is a way on the calculator. Second, calculate, and take a wild guess from the list of choices you have there. Ah, maximum. Maximum is correct. Hit 4, which is maximum. Now, it doesn't just tell you. Because the graph might have lots of maximums, it wants to know the little interval where you want to look at. So you want to get close to where the maximum is, be to the left of it, and hit enter, and then go to the right of it, to the right of where the maximum is. Doesn't even matter how far to the right, but I'm now to the right of the maximum. I hit enter. Do you see the two little things that popped up right here? You see those? That tells you the left end and the right end. That's important. That tells you where you're looking. Okay, and now the last part is guess. Do you remember what you're supposed to do on guess? You get really close to where the right answer is. All right, so I'm going to hit arrow. I'm arrowing to the left. My calculator's dying. I got the blue ring of death. This is not good. That stopped. Okay, good. Okay, so now I'm close. I'm getting closer. It's close enough. You don't have to be super close. Some kids get really picky about it. I think I should move over a little bit further. Doesn't matter. If you get close enough, then they'll just hit enter and it'll jump to the right spot. And the maximum is at, well, do I want the x or do I want the y? It's an interesting question. If they wanted the point, I would say both numbers. I would say 0.8, comma 1.2. But if you want to know what is the maximum, which one tells you the highest it went? The y. Okay? So the y is 1.19, or you could round that to 1.2. So 1.2 is the maximum. The zeros. What the heck is a zero? The zeros are the x-intercepts. The x-intercepts are where it touches the x-axis. But there's an app for that, so to speak. Go to second, calculate. We want the zeros, so choose 0. Once again, it's got a little bit of directions I got to show you. All right, left boundary. The 0 is this spot right here. I missed it. There, right there, to the left. My marker's really wide. But anyway, that spot on the left, if I want to be to the left of that, I need to arrow my little spider thing to the left of it. There, now I'm to the left. I know I'm underneath it, but I'm also to the left of it. And I hit enter. And then right boundary, arrow just to the right. I strongly recommend you get used to using your calculator for this because you'll have to do this in the test. You will not be able to do it by in your head or by hand. the guess, get right on top of it, and there I am. Look at that. It's at 0, 0. So obviously that's a pretty easy answer. 0. What we're finding here are the x numbers, in case it mattered. What? Good question. If you say x equals 0, that's actually a line, but it's also okay to write x equals 0 for the zeros. So yes, it's better than saying y equals, because that would be wrong. These are x numbers. The zeros are x-intercepts, so it's where it touched on the x-axis, and where it touched was 0. There's another spot it touches, though. So the other spot I got to do, again, I got to second calculate the zeros, number 2, and then I go to the left of it, but it's a different spot. I got to get closer to it. There, I'm to the left of it. I know I'm above it, but that doesn't matter. I'm to the left of it. And then I also go to the right of it. I wish it would say under it and over it, but it doesn't. And then the last part is guess. I'm going to arrow back to right. Look at that. I'm almost on top of it, but who cares? Because it'll tell me the exact answer when I hit enter. And do I want the x's? Yes, I do. Because the point is that the y is 0. That's what an x-intercept is. Y will always be 0. So don't ever write down 0 for these unless you're actually at x equals 0. All right, so anyway, the x equals is what you want. It's 1.259. I would round it to probably 1.3. If we want exacts, we'll tell you that. It's about 1.3. 1.25 is fine. 1.26 is even better. All right. Now let's move on to problem 6. Thankfully, you don't have to graph all of these things, because the ones that you're graphing takes kind of a long time. All right, number 6. Use your understanding of end behavior and y-intercepts to match the polynomial with its graph. Ooh, it's matching. I like those. Number 6, I would suggest you start by saying, what's its y-intercept? 104. Look at all the graph choices. You now have narrowed it down to only 2 of them have a y-intercept that's even positive. You get that. Now, it's hard to know which one it is. But if you look at the little numbers underneath the graph, you can tell what the x's are counting by and what the y's are counting by. Okay? But I guess what I would suggest is let's go a little bit further, because those two graphs are, could be like, we could go a little further, put it that way. Do you get that number 6 has 7x cubed and therefore it is an odd one? If it's an odd one, the ends have to go different directions. But wait, that doesn't help us too much, because both of mine that have positive y-intercepts are what I would call A and C. Which one is it? Well, I have to look closer now. Which one is it? Some people say an A, some people are saying C. The y-intercept's 104. Which one of them are you sure is touching just above 100? I agree. C. It's C. It's just above 100. All right. I think that's good enough on that. And the last is number 10 and 11. We spent a lot of time practicing limits, so I think you'll be fine there. Remember, it always starts with lim of f of x as x approaches, and you just have to fill in those last 2 spots. Okay, that's all I got for you for today.